Salutations, soul siblings, and welcome to today's guided meditation. At whatever and wherever point you find yourself now during your busy day, I invite you to take this moment to yourself. Close your eyes and let your mind wander. We'll begin our practice by taking 3 deep breaths together, in through the nose and out through the mouth. As you exhale, allow any tension you are holding in your body to release in whatever way that body tells you. Sink deeper into your chair. Let your feet melt into the floor, and together we'll breathe. In, out. Ah! In. Out. Ah! In. And one last time. Out. I got you. Bet you were expecting me to scream, weren't you? Now, I don't know about you, but I'm feeling mighty relaxed and ready to solve some more polynomial equations. Welcome to class 10 of Unit 7, Solving Polynomial Equations, Part 2. Now remember, if my goal is to solve a polynomial equation like 2x squared minus x equals 3, well, we came up last time we were together with a 4-step strategy that could get us to that solution set without fail, provided, of course, that we know how to factor. So, take a look back at your notes, give yourself 30 seconds. What are those 4 steps that we might want to follow, and in what order to arrive at our solution set? And for 2x squared minus x equals 3, if you're feeling bold, give yourself a little bit of time, see if you can arrive at that solution set yourself, and then we'll come back together and chat. Go ahead. All right, let's do it. So, 2x squared minus x equals 3. If I want to solve this, I know that the tool that's going to get me there, the answer to my prayers, the solution to my problems, is the 0 property. And the 0 property, of course, does not work unless there's a 0 on one side of my equation. So my opening move should be to take my equation and get one side of that equation to equal 0. In this case, the easiest choice to make to accomplish that goal, we'll notice that 3 is all off by itself on the right side. I can move it over to the left using subtraction. So here I've got 2x squared minus x minus 3, gonna leave it in standard form, is equal to 0. Fantastic. So there's my first move. I got a 0 on one side of my equation. And once there's a 0 on one side, of course, well, now I know that the left side, that 2x squared minus x minus 3, that friend is looking mighty factorable. So my second move is to factor the other side of my equation. Well, 2x squared minus x minus 3. It doesn't have any greatest common factor moving through my checklist one by one. It is not a perfect square trinomial, it is not a difference of squares, and it is not factorable by grouping. But it is a quadratic trinomial, which means that if it is factorable, it is likely, in fact, definitely, going to be the product of 2 linear binomials. So, for the first slot, I know that at the front, when I do my met wet back out, I need to multiply to get 2x squared. Well, the only way that I'm getting there is going to be 2x times x. At the back, I know that these guys are going to multiply to get negative 3. Notice that my leading coefficient is not 1, so that special pattern of adding to our middle coefficient, unfortunately, does not work here. But negative 3, it could be either negative 3 and positive 1, or positive 3 and negative 1. Well, I know at the front, it's got to be 2x and x. If we do enough trial and error, it turns out that 2x minus 3 and x plus 1 will do the trick. If you don't believe me, do some quick met wet. 2x times 1 gets us 2x. Negative 3 times x gets us negative 3x. Add them together, there's that middle negative x that we want. Lovely. Now, I know that the product of these two things is equal to 0. And by our friend the 0 property, that tells me that if these two multiply together to be 0, then one of them must be 0. So using that 0 property, I am now going to take each of my factors and set each of them equal to 0 independently. Once I do that, I can find the value of the variable that makes each of my factors equal 0. So by the 0 property, this tells me that either, if their product is 0, then either the 2x minus 3 is my 0, or the x plus 1 is my 0. Now that I've got it, all I need to do is solve those linear equations, and I'm home free. Well, if 2x minus 3 is equal to 0, again, my goal is to get x by itself. Let me add 3 to both sides. That tells me that 2x is equal to 3. And if I want to get x by itself, well, the last thing standing in the way is that pesky 2. X could be equal to 3 halves. Or in my second case, if x plus 1 is equal to 0, minus 1 from both sides, here x could be negative 1. If I wanted to be really annoying, I could also take this solution set and write it in my set builder notation. Well, on my number line, negative 1 comes first, so it's going to go first in my set builder notation, followed by 3 halves, close it with a squiggly bracket, and here is our solution set. Cool! Now, to make sure that it's really sunk in, let's do some practice. We'll take them 2 at a time. Again, pause the video, give yourself 2 minutes, work through each one. Once you feel like you've got a good handle on your equation, come back and check with me. Go! Alrighty. Now for number 1, 4g cubed, 8g squared, 4g. I see lots of multiples of 4, lots of multiples of g. This guy has a GCF. Now 4, 8, and 4, both of these are multiples of 4. G cubed, g squared, and g. I'm going to take my smallest exponent of invisible 1. 4g is my greatest common factor. So all I need to do now is figure out what goes in those parentheses. Well, to get from 4g to 4g cubed, I would need to multiply by 2 copies of g. To get from 4g to 8g squared, I've got to multiply my 4 by a 2 and my g by a second copy of g. And to get from 4g to 4g, well, I just need to multiply by 1. Now, inside of my parentheses, you'll notice g squared plus 2g plus 1. This guy is a perfect square trinomial, my little pumpkin spice trinomial. And I know that g squared plus 2g plus 1, if I remember my perfect square trinomial pattern, is g plus 1 quantity squared. Right, I've got a plus sign in the middle, so there's a plus sign in my factor. G times g gets me my g squared, 1 times 1 gets me my 1. And all of this, of course, is equal to 0, which means, stop dying, Mr. Volel, I can now use my 0 property to set each of my factors to 0 individually. So if the product of 4g and my g plus 1 squared is equal to 0, then either the 4g is the 0 or the g plus 1 is the 0. If 4g is equal to 0, all I need to do is divide both sides by 4 to get g by itself. Here, the value of g could be 0. Or if g plus 1 is equal to 0, just like above, subtract 1 from both sides. Here, g could be equal to positive 1. The only thing that I'm going to say is because I had 2 copies of the factor g plus 1 in my original polynomial, there are going to be 2 copies of g plus 1, or g equals 1 in my solution set. This guy is a double root, abbreviated dr. If I want to be really annoying, right, let me give myself my solution set notation, or solution set in set builder notation. 0 comes before 1 on the number line, so 0 comes first inside of my little set builder. And then for 1, I'm going to give myself a little times 2 here, just so I know that it is a double root. 12m squared equals 15m. So again, here I do not have the luxury of beginning with a 0 on one side. Let me start by moving that 15m over to the left. Now don't fall into the trap. These are not like terms. I cannot actually subtract them. This is 12m squared minus 15m equals 0. Well, 12 and 15, both of these are multiples of 3. M squared and m, I can take one copy of m out of both of these. There is my greatest common factor. Now 3m to get to 12m squared would be times 4m. To get from 3m to negative 15m, well, I just got to multiply by negative 5. Once again, by my zero property, if their product is 0, then one of them must be 0. So 3m could be 0, or 4m minus 5 could be 0. Now, solving for m, again, I'm going to divide both sides by 3. In my first case, m could be equal to 0. And in my second case, if 4m minus 5 is 0, well, reverse order of operations, let me start by doing my addition subtraction. Here, 4m would be equal to 5. Dividing both sides by 4 would tell me that m is equal to 5/4. If I want to be annoying, right, in my set builder notation, 0 is smaller than 5/4, so 0 comes first. Close both sides with a squiggly bracket. There we go. Moving on, let's do 2 more. Again, give yourself 2 minutes, work through each of these examples. Once you feel happy, or maybe you don't feel happy, I don't know, I can't control your mood, come back and check with me. Go ahead. Alrighty. Now for number 1, 2 minus 2w squared equals 3w cubed minus 3w. We've mentioned in class that it's usually nice if we keep our leading coefficient positive. So this 3w cubed, it's already positive. I want to leave it on the right side. So it's actually wiser for me to move everything else over to the right. So I'm going to add a 2w squared to both sides. And then I also have that 2. So in the same line here, I hope you don't mind if I add 2w squared and subtract 2 simultaneously. On the left, of course, this gets rid of both of those friends. That leaves me with the 0 that I want. Writing in standard form, I've now got 3w cubed. I'm going to put my 2w squared second, my negative 3w third, and my negative 2, bringing up the rear. Well, notice this friend has 4 terms. Let's factor by grouping. So I'm going to drop my big old dividing line. So 0 could be equal to 3w cubed and 2w squared. Notice both of these have 2 copies of w. So w squared is my GCF. Take w squared out of 3w cubed, that leaves me with 3w. Take w squared out of 2w squared, that leaves me with that plus 2. Thinking strategically. Once again, I know that my factoring by grouping pattern only works if the same thing shows up in my parentheses. So I'm going to put the 3w plus 2 there preemptively. Notice to get to negative 3w minus 2, it's got to multiply by negative 1. Last step in my factoring by grouping pattern, well, my parentheses, 3w plus 2, I'm going to bring those down, give it its own parentheses, and then my leftovers, the w squared minus 1, gets its own parentheses as well. But wait! There's more. W squared minus 1. W squared is a perfect square. 1 is a perfect square. Joined by subtraction, this guy is a difference of squares. And I know that my difference of squares pattern factors as follows. So I'm going to bring down my 3w plus 2. W squared minus 1. Well, it's got to be something times something. The numbers in each slot are the same, but the difference of squares is going to give me my difference of signs. 1 gets a plus, 1 gets a minus. At the front, w squared is w times w. At the back, 1 is 1 times 1. Now, using my 0 property, I've got 3 factors that I can set equal to 0. So either the 3w plus 2 is my 0, or the w plus 1 is my 0, or the w minus 1 is my 0. If 0 is 3w plus 2, well, I'm going to subtract 2 from both sides. That leaves me with negative 2 is equal to 3w. Divide both sides of my equation by 3. Here, w could be negative 2/3. If 0 is equal to w plus 1, once again, I'm going to subtract 1 from both sides. Here, negative 1 could be the value of w, or in my last case, if w minus 1 is equal to 0, adding 1 to both sides reveals that my final possible value of w is positive 1. In my set builder notation, I'm going to give myself my squiggly brackets. The smallest of these numbers is negative 1, followed by negative 2/3, followed by 1. There you go. here's your solution set. 2r squared equals 3r plus 2. Once again, I don't like that I don't have a 0, but I want to keep the 2r squared positive, so let me now move my negative 3r negative 2 over on the right. On the right side, both of those cancel out. That leaves me with the 0 that I want. On the left, I've got 2r squared minus 3r minus 2. Well, 2r squared minus 3r minus 2, look at that. That is another quadratic trinomial, which means that it's going to double factor into the product of two linear binomials. Well, at the front, to get to 2r squared, it's got to be 2r times r. So let me slot those in, 2r and r. At the back, negative 2 could be negative 2 times positive 1 or positive 2 times negative 1. If I try out enough options, I will find that the negative 2 at the back and the positive 1 at the front does the trick. If you don't believe me, 2r times negative 2, there's my negative 4r, plus 1r gives me the negative 3r in the middle that I need. Now, using my 0 property, I'm going to take each of my factors and set each one to 0 individually. So 2r plus 1 could be my 0, or r minus 2 could be my 0. If 2r plus 1 is my 0, subtracting 1 from both sides, this leaves me with 2r is equal to negative 1. Dividing both sides by 2, I find that r could be negative 1/2. Or, for my other case, if r minus 2 is equal to 0, adding 2 to both sides, well, this reveals that r could be equal to positive 2. Once again, if I'm so interested in writing my set builder notation, negative 1/2 comes before 2 on the number line. There you go. Close them in your squiggly brackets, and we're happy.